Hi guys, today we're going to be looking at a question on photoelectric effect. Question 10.1. Define the term photoelectric effect. So, photoelectric effect is the process whereby electrons are ejected from a metal surface when light of a suitable frequency is incident on that surface. Question 10.2. Red light, blue light, and green light are shone simultaneously on a sheet of potassium as shown in the diagram below. Each color of light consists of a single frequency. Two maximum kinetic energies of the ejected electrons are possible, namely 6.96 times 10 to the negative 20 joules and 2.65 times 10 to the negative 20 joules. Each ejected electron has only one of these maximum kinetic energies. Question 10.2.1. Which color of light is responsible for ejecting electrons that have a maximum kinetic energy equal to 2.65 times 10 to the negative 20 joules? So, as we know, there's red light, blue light, and green light. Red light has the lowest frequency as it has the highest wavelength. Blue light has the highest frequency and the smallest wavelength. And green light is in the middle. So, red light, since it has the lowest frequency, would be the most likely to not be able to eject electrons. Blue light will eject electrons that have the highest velocity, and green light will eject electrons that have, in this case, the lowest kinetic energy. So, for this question, since 2.65 times 10 to the negative 20 is less than 6.95 times 10 to the negative 20, the color of light responsible for this would be green. Question 10.2.2. As we have said, only blue and green light will eject electrons, as red light does not have enough energy and has a too low frequency to eject electrons. Since green has a lower frequency than blue, green light will eject electrons at a lower kinetic energy than the blue light. Question 10.2.3. The electrons with a maximum kinetic energy of 2.65 times 10 to the negative 20 joules are ejected by light that has a frequency of 5.85 times 10 to the 14 Hz. Calculate the frequency of the light that ejected electrons with a maximum kinetic energy of 6.96 times 10 to the negative 20 joules. To do this, we can say that the energy is equal to the work function plus the maximum kinetic energy. We can then calculate our work function from the two values we have already, energy being broken down into H times F, H being a constant given, frequency being 5.85 times 10 to the 14 is equal to the work function plus 2.65 times 10 to the negative 20. And if we rearrange and solve for work function, we get work function to be equal to 3.61 times 10 to the negative 19 joules. We can then use the work function in the same equation to calculate the frequency of the light needed to have a maximum kinetic energy of 6.96 times 10 to the negative 20. So we can again say 6.36 times 10 to the negative 34, being H, frequency, which is what we want to calculate, is equal to the work function, which we have just calculated, plus the maximum kinetic energy. And if we rearrange and solve for F, we get the frequency to be equal to 6.5 times 10 to the 14 Hz. Question 10.2.4. The intensity of the red light is increased, while the intensities of the blue light and green light remain the same. What effect will this change have on the rate at which electrons are ejected? Choose from increase, decrease, and remain the same. Since we know red light does not have a high enough frequency in order to emit electrons, even if the intensity is increased, it does not change the energy that the light has. It just changes the amount of energy that hits the surface per second. So, therefore, electrons will still not be ejected when there's red light. And since the blue light and the green light remain the same, this will not change the rate at which electrons are ejected. So we would say remains the same. I'm going to do the next question on a new page so you can see it more clearly. Question 10.3. Some of the atoms of a hot gas made up of a single element are in an excited state. The spectrum formed by the hot gas is observed on a screen in a darkened room. The spectrum consists of specific colored lines on a black background. Question 10.3.1. Name the type of spectrum formed. Sorry, this is one. The type of spectrum formed is an emission spectrum, as we are looking at a hot gas that is formed and it forms colored lines on a black background, therefore being an emission spectrum. Question 10.3.2. Explain the presence of colored lines in the spectrum. So the colored lines in the spectrum represent frequencies of the emitted atoms or electrons as they move to a lower energy level, as it is a hot gas and they are in an excited state. And that's all for this video. Thank you.